Alright, so in this lesson we're going to learn about the imaginary unit I. Again, we've discussed where if we take the square root of a negative number, we're going to put no real solution. The reason that we keep considering no real solution is the fact that you can take the square root of a negative and end up with an imaginary number. We'll look at kind of the spectrum of what we understand about real and imaginary numbers. The reason this is so hard for some of us to grasp initially is because we've never really worked with imaginary numbers. So the first thing that we want to focus on is the fact that the imaginary unit is I. And anytime we have something that's imaginary, we're going to have an I term of some kind in it. I is equal to the square root of 1, and so the other thing that they draw our attention to is that if I take I squared, it's equal to negative 1. So when we have I squared pop up later on down the road in some of our problems, we're going to know that I squared is equal to negative 1, and it actually takes it out of that imaginary plane and makes it something that we're more familiar with. So the core concept box, again, if R is a real positive number and you take the square root of a negative number, you're simply going to put an I outside of the radical symbol, and you're going to leave your square root of whatever it is. Now, the example they gave us is the square root of negative 3, so we would just put I square root 3. We'll see some more examples that help this be a little bit more concrete, so I'm just going to continue here. So in this one, what we're going to do is we're going to find some imaginary answers. Again, we know that the square root of 25 is 5. So when we go to do example A here, we're just simply going to say the square root of negative 25 is simply 5i. And sometimes you'll see a plus or minus there. Square root of 72, again, no different. We need to do the ladder method. So if I ladder out 72, I'm going to divide by 2 and get 36. Divide by 2 again, and I'm going to get 18. Continue dividing by 2. I get 9. 3, 3, 3, and 1. So we're going to take anything out that we can. So 3 times 2 is 6. The I comes out as well. We leave the square root of 2 underneath. So we're going to say 6i square root 2. Again, we already have a negative sign out there, but when I take the square root of negative 9, I get 3i, or I times 3. So when I go to solve this one, it's simply going to be negative 15 times I. Again, it's going to be pretty easy early on. We're going to add some things that make things more complicated. So go ahead, pause the video and try these. I'm going to pause my recording as well, put the answers down, and then I'm going to allow you guys to unpause and see if you did it right. Okay, so hopefully most of you guys could figure out these. 2i on the first one. Again, most of what we're doing in this part of it is simplifying radical expressions. Anytime you see a negative sign, you're going to take out that imaginary part and put it on the outside. So 2i, you get 2i square root 3 for number 2, negative 6i on number 3, and then hopefully you guys kind of followed what I did here. I showed the work of simplifying the square root of 54. I could take out a factor of 3. I wrote it on the outside with the I. The square root of 6 stays on the inside because I multiply the factors that don't get to come out. Notice I copied the 2 down out in front that was already out in front at the beginning of the problem. Then we multiplied both parts that were on the outside. So hopefully that's not too terribly bad. So again, like I talked about earlier, we have this complex number that's kind of frustrating for us at first because everything that we've worked with so far has been in the real plane. So we've talked about real numbers like the integers, whole numbers, rational numbers, and even irrational numbers, which again we don't use too much, but irrational numbers are non-terminating, non-repeating decimals. So, things like pi or the square root of anything that is not a perfect square. Whereas we start to see these imaginary numbers that end up in an imaginary plane. Now again, imaginary numbers sometimes have a real component to them, like you see up above. pure imaginary numbers don't even have that real component. So understand that they're essentially the same thing. They're still imaginary, but when you see the term pure imaginary, that just means that your real component of it is 0. In example 2, they want you guys to be able to solve for some variables. If you'll notice up above, basically what we're going to do is we're going to set the real parts equal to the real parts and the imaginary parts equal to the imaginary parts. So when I go to do this one, I'm going to set 2x equal to the other real part 10 to be able to solve for my x variable, and then I'm going to set negative 7i equal to y times I for my imaginary part. I'll divide by 2 on the left, and I will get x equals 5. And then to find y, I can divide by I, and that imaginary part will just cancel out, and I'll simply get y equals negative 7. So again, we're just finding the value so that x and y satisfy the equation here. So essentially just set the parts equal to each other that go with each other. Again, it shouldn't take too long. Pause it, try these real quick. I'm going to put the answers up so that it doesn't take up a bunch of the video. Then you can unpause and look at my work. So you guys can see here again, you just set the parts equal to each other that go with each other. So x is the real part with 9. 3i is the real or the imaginary part with negative yi, and then you just isolate your variable there. Same thing over in number 6. Fraction answers are okay. Don't worry about switching them over to decimals. I'll accept either or, but you don't need to waste your time with a calculator. Negative 9/2 and 3/4 are just fine. So again, we'll do some operations now on these complex numbers. The first part of the section is understanding what a complex number should look like. Again, most of the complex numbers we work with early on will have a real component and an imaginary component. Again, some of the basic operations that we'll do on them is addition and subtraction. Just make sure that you guys are paying attention to your signs, and you should do just fine on this because it's pretty similar to what we just saw. So in this first example, I'm going to combine my like terms of the real parts and the imaginary parts, but this time we have sums and differences that we're working with. So in the first one, for example, 3a, I'm going to add 8 plus 5, and I'm going to get 13. And then for my imaginary part, I have negative I plus 4i, which is positive 3i. And that's all the farther I can go with that. So that's it. Next one, b, I have 7 minus 3, which is going to give me 4 for my real part. And then sometimes we kind of overlook this, but I have negative 6i minus another negative 6i. So this actually cancels out because we add here, and that makes my imaginary part 0 times I. 0 times anything is still 0, so my answer to B is actually just 4. Letter C is trying to confuse us. Again, we have to follow our properties of algebra, so I have to distribute that negative sign through, and when I do that, I get negative 2 minus 7i plus 5i, and then all I need to do is combine it so that it looks like an imaginary or a complex number. So I have 13 minus 2 is 11, negative 7 plus 5i is negative 2i. So now we're going to multiply some complex numbers again. We just have to pay attention because every now and then we'll end up with an I squared. And if you'll recall from the beginning of the lesson, I squared is actually equal to negative 1. So when we have that I squared, we have some cleaning up to do before we can finish and write it as a complex number. So when I distribute on 5a, when I distribute this, I'm going to have 4i. Then I need to take through the binomial negative 6 plus I. So 4i times negative 6 gives me negative 24i. And then 4i times I is going to give me positive 4i squared. Again, this 4i squared right here, 4i squared is really equal to 4 times negative 1. So I have negative 24i plus 4 times negative 1. So 4 times negative 1 gives me negative 4. That's my real part. That's going to go out in front. Minus 24i, my imaginary part, I'm going to move it to the back. And that's my answer. For part B, we're just foiling. Again, just keep your I terms straight. You'll have some I squareds pop up in here, but just watch what you're doing with your math. So I have 9 times negative 4 is negative 36. 9 times 7i is going to give me plus 63i. Negative 2i times negative 4 is going to give me positive 8i. Negative 2i times positive 7i is going to give me minus 14i squared. Okay, so this is about as busy as it gets in this section. We just have to clean up and put together like terms. Again, pay attention to when you have that I squared, because we have to make that back into what it means, which is negative 1. So I have negative 36. We're going to leave that alone for the time being. Then I have 8 plus 63, which gives me 71i. And then I have negative 14 times negative 1, because I squared is equal to negative 1. So that negative 14 times negative 1 gives me positive 14. So I have negative 36 plus 14 plus 71i. 71i. Alright, so when I combine like terms here, I get negative 22 plus 71i. And that's your final answer. Again, you want the real part first, then your imaginary part in that complex number. Okay, so once again, pause the video, do the correct operation on these complex numbers. Make sure you simplify your I squareds. And once you're done trying them, go ahead and unpause the video and look over the work. I'll kind of discuss it quickly. Again, you guys will be able to ask questions in class. Okay, so again, just combining like terms there. 9 minus 6, you get 3. Negative 1 plus 7, you get 6i. Number 9, 3 minus 8, you get negative 5. 7 minus negative 2, you get positive 9i. Really watch for those double negatives. On number 10, we distribute the negative sign through both sets of parentheses, essentially. Watch your signs, combine like terms, and you should get negative 10 minus 10i. Number 11, you're multiplying those two together. Again, notice you get an I squared. We change that to negative 1 and then multiply it by the number out in front, so we just get positive 30 for an answer. Number 12, distribute the I through, and you get 8i minus negative 1, essentially. So we put that positive 1 out in front and write it in complex form. Then the next one, we FOIL. You guys can see all of my terms there. Again, notice we have that minus I squared on the tail end, which technically will give us plus 1, and we will combine like terms with our coefficient out in front. So again, a lot of this is just once we know what it should look like, making sure that we don't make sign errors along the way.